Greetings. Welcome to our 30th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we are going to focus on our June 3rd, 2021 webinar titled Designing Double-Line Containment Systems Using Flexible Geomembranes. I'd like to quickly reintroduce our three speakers. Brian Fraser, who's been working in the geomembrane business for 41 consecutive years, including manufacturing, fabrication, and construction. Brian's lived in both the US and Canada, and he's currently Vice President of Layfield Geosynthetics, based in Edmonton. Next is Matt Chemnitz, who is President of Leak Location Services, Inc. LLSI has surveyed over 500 million square feet of geomembrane and almost 4,000 project sites all over the globe. And Matt is based in San Antonio. Next is Rohit Sethi, who is also with Layfield in Edmonton. He's with the Technical Services Group and is a technical product manager responsible for geomembrane containment products. Okay, so Brian, Matt, Rohit, thanks for joining us again.
Thank you.
Great. And we didn't get through all of the webinar questions, as you probably remember, and we received 10 more new different questions after the webinar. So I'd like to run through all of these questions with you. So here's the first question. How can you compare the performance of different types of geomembranes? For example, when tensile properties do not follow the same standard test methods. For example, a PVC and a TPO geomembrane.
Thanks, Tim. I'll take that question. Now, geomembranes, they come in different shapes and sizes. And what I mean is, they can be differentiated based on, the polymer type, whether it's a PVC or a polyolefin material, like an LLDP or an HDPE. It could be a polyurethane-based material, et cetera, whether it's a scrim-based material or it's an unsupported geomembrane. Thickness variation. The geomembranes start at about 30 mil, and you can actually see geomembranes go up to 100 mil thick materials. Finishes are critical, whether your geomembrane has got a textured finish or a smooth, whether your geomembrane has got a conductive finish. These are all the factors you have to consider when you're selecting a geomembrane. And one should look at not only the material side of things, but you should also look at the constructability around the project-specific site. So when you're talking about material, you got to look at whether your application is exposed, backfilled. If it's a seepage control application where you can actually use a standard grade geomembrane, whether you're looking at standard containment, where you got to use like a minimum 30 mil geomembrane, or in a critical containment application where you have to look at something like a double line pond. So performance properties are basically very specific to project specific needs. Just as an example, you're probably looking at higher tensile material or something with reinforcement if you're looking at a cutoff curtain or you're looking at a baffle system. When you look at installation, some things that come to your mind are factory versus field assembled geomembrane. So your material choice can also deviate based on some of these constructability related questions. And lastly, you can also look at doing some long-term performance testing to determine the before and after performance so that you can gauge the performance of the right material for your application.
Great, Rohit. Thanks for that detailed answer. Next question is testing of factory fabricated seams observed and documented by third-party CQA consultants? And Brian, could you take this question?
Yeah, certainly, Tim. Yes, similar, I guess, to larger or more commonly on larger, more critical type projects, we will see third-party QC companies or engineering firms both come into our manufacturing plant, but also our fabrication plants. And Obviously, monitoring our fabrication and our testing records, looking over our pre-qualification welds, both destructive and non-destructive testing, frequency of testing, and reviewing our work instructions, our packaging standards are very, very common. But certainly, specifically firsthand auditing, our peel and shear values of our seams, etc. Not happening every day, but certainly does happen again on larger, more critical projects.
Yeah, Brian, and along that line with factory fabrication, you're usually testing in the factory test welds, like before you start, maybe during shifts, not destructively sampling the actual finished geomembrane for the site, correct?
Yeah, again, every project or specification is different, but yeah, normally on the factory fabricated panels, we're definitely doing our pre-qualification welds, morning coffee breaks, start up in the lunch or after lunch. There are specifications that want a certain amount of testing. For instance, you could have specifications where every 500 lineal feet need to be either destructed or non-destructive tested, or typically a destruct. And in those cases, we would pull the coupons and do peel and shear values. So, but it is mainly the pre-quals that everyone's keying in on.
Right. Okay, next question. Isn't electric leak location testing of the secondary liner more critical because it is the containment barrier or liner? The primary is just to reduce head on the secondary liner system. So Matt, if you could handle this question.
Gladly. Okay, so what we typically have seen historically on a double line system is that the primary would be tested, find all the leaks and repair them, and then that way there's nothing being collected in the leak detection zone. But then if you think about it, which this question alludes to, is if your secondary is not tested, kind of why is it there, and it's not being tested. Now, what I will say is once the secondary liner is covered by a primary liner, you can't go back and test that secondary. So if it's installed and you're questionable about the installation or there being leaks, it should be tested at that point. And we're starting to see this happen more and more in certain states around here, is that the secondary must be tested and the primary tested. And that's starting to kind of make some headway. And I think that's good, of course, because many times we do get a call to test the secondary once it's been covered, and there's nothing you can do about it.
Right. Great point. Okay, next question. How is conductive liner successfully welded to avoid false positives through the wedge welded seams, which was discussed in the webinar? So Rohit, could you start with that question?
Yeah, for sure. Yeah, I think as you said, I think Matt brought up this issue during the webinar, because if the seams are not done right, it can create a lot of issues for the leak location contractor, like Matt. Now, in terms of how successfully you can weld the seams, I would refer to the manufacturer's MQA document or manufacturer's quality assurance document, and also the installation details to ensure that you have the right information in front of you. One thing I know that it's definitely a tedious process to ensure isolation of these welds across the seams. It definitely takes longer than what you will see with a standard geomembrane. Matt, do you want to add anything to that?
Yeah, we don't do any welding. We've seen a lot of welding. Essentially, the idea is to get rid of that extra flap on the primary so that conductive underside of the flap is not giving you your false positives. The more false positives you have, the more current is going to those flaps and not the actual leaks. So we want to get rid of any possible grounding or issues such as this. There are different welders out there and different ways to do it. And basically, when it does the double wedge weld, it cuts off that flap to basically isolate that from the system. So again, there's different options out there, but it really the suppliers should be telling the installers how to do it and to kind of get them through that process. Because it can definitely be a problem for doing these leak location tests.
Right.
Great, thanks. Next question. Polyolefin alloy is from HDPE, and what else? Brian, why don't you start with that? Question's not perfectly clear.
Right. So for this webinar, we of course we're trying to keep generic on the brand name. It's a very mainstream product used in the United States, Canada, Australia, as well as South America. So when we say polyolefin alloy, we're blending two different resins, and it's basically a combination of HDPE, known for its chemical resistance, and linear low density polyethylene, really known for its flexibility and very good tensile properties. That and it's combined with a really advanced UV antioxidant package and quite heavily stabilized in terms of its amount of antioxidant. And so it's a product developed, produced really from 20 mil to 80 mil. And we've really designed it as a fabricated liner, and we can prefabricate the material right up to 50 mil. And above 50 mil, we're field installing it, and has gone through a couple formulation tweaks and updates over the years. Yeah, that's really what we're referring to, a blend of HDP and LLDP with an advanced UV AO package.
Great. Next question. If you have saturated brine, are we talking about sodium chloride brine? And this gets to the case history you discussed, Rohit.
Yes, exactly. I think that's definitely saturated NaCl brine. And I think in the webinar we also discussed about some of the testing where we simulated the brine solution. So the brine makeup was definitely sodium chloride, and that was the majority of it, with some sodium bicarbonate and sodium carbonate added to adjust the pH at about 9.5. Yes, it is largely NaCl brine.
Okay. Next question for you, Rohit. Did you consider the evaporation rate in the pond in your case history under the ambient conditions? Would you have solid particles after the water loss?
It's a good question. However, this project that we talked about was a brine pond and not an evaporation pond. So these brine ponds that are used by energy producers, they use brine to extract the natural gas from the gases that are stored underground or in the salt caverns. So they will actually pump the brine into these caverns to extract the natural gas, when there is a demand. I would say, it's like 40-50% time. I mean, this brine is actually under the ground, and the likelihood of evaporation is largely reduced. So I think her question is more in relation to evaporation ponds, where you can actually see the residue or the solid particles, that remain after the evaporation loss.
Right. And you prepared a project spotlight on this particular project, right?
That's right.
Yeah, so this viewer can visit the FGI website and also download the project spotlight, which provides some additional details on the pond and the brine that's in it.
Exactly.
Okay, thank you. Next question. How do you prevent bridging at toe slopes, or the toe of slopes? Brian, could you handle that?
Yep, certainly, Tim. Typically bridging is more recognized as a problem with steeper slopes or vertical walls. We don't commonly see it as much, say, at 3-to-1 or 4-to-1 slopes, but as you get 2-to-1 or 1-to-1 or straight verticals, we get a little bit more concerned with bridging. And really, at that point, it's critical that the installer and their technicians are making sure that right at toe of slope, that we have the material laying flat We like to see some slack built into that. Of course, normally we're doing the installs and more in summer and fall, and as materials get much colder in the winter months, we can see contracting. So we like normally to place a slack wrinkle right at the toe, and as we get, say, thermal extraction, contraction, we have enough material there so that we don't see any bridging, and which is a concern. And but properly installed, we typically don't see that problem.
Great, thanks. So now I'd like to shift to the questions that we received after the webinar via the post-webinar survey form. And there are 10 of them. So here we go. Number one, a comment to thank the panel for their insights. Thank you. Would like to have a copy of Rohit's paper on interface shear strength of materials and thicknesses. So Rohit, can you make that available?
Yeah, I think I was not referring to my my own paper. I think I was referring to an industry paper. And yeah, I mean, I'm sorry. I mean, I haven't looked at that specific paper I was talking about, but I will. I'll search for it and I'll send it to you, Tim.
Yeah, that's great. Or just let me know which paper you mentioned. And
yeah, and one of the things that I was even thinking for FGI to perform was to do some interface friction testing on fabricated materials, so that we have some database on how what the performance is, what the peak friction angles are and stuff like that. I think that would be an interesting study if we can do something on it through FGI, Tim.
Yeah, that would be great. We're running quite a bit of geosynthetic interface testing right now, so we could easily put some more materials into it. So great. Next question. How do you transport a 20,000 to 40,000 square foot prefabricated panel that has a complex geometry? So Brian, why don't you handle that?
Yeah. Again, normally, again, we make square panels, rectangular panels. There are times we make custom tapered panels, and these can, typically average, anywhere from, to 20 to 40,000 square foot. So if you take in the middle of that, a 30,000 square foot panel, say for instance on a 40 mil material, would be roughly about 6,000 pounds. And normally we're winding those in our factory somewhere around 8 foot widths, and again a 3,000 pound or 6,000 pound panel would probably be somewhere around a 6 to 8 foot diameter. And so we're putting these on a custom 5 foot by 8 foot heavy duty pallets. They have a protective plastic underneath them to prevent any possibility of damage from pallet staples or nails. They're wrapped with geotextiles and shrink wrapped. Again, every manufacturer, fabricator does it slightly different. But these 4 to say 6,000 pound panels are normally palletized, come with lifting straps. They also have cores in the middle that you can pick up, and so shipped to site normally on flat deck trucks. And of course, zoom booms or backhoes are used on site to remove the prefabricated panels.
Thanks, Brian. Next question. This viewer would like more detailed installation procedures for the different liners / geomembranes and what to watch for to protect the geomembrane. So Rohit, if you could start with that, and maybe Matt, you might have some ideas of how to protect the geomembranes.
Sure. Again, this question could either be for fabricated geomembranes or for field installed geomembranes. And if it's field installed, you can look at the guidelines provided by IAGI, International Association of Geosynthetic Installers. And I think FGI has got some white papers already available on the website where we can actually go and look into detailed installation procedures for different liners. I mean, for most flexible liners, the installation procedures are very similar. And in terms of liner protection, we have, if you go to Layfield's website, I mean, there is a tech note on, backfilling geomembranes and how you can protect your liner from puncture. It could be a long discussion, so I will leave it here. But there are different ways to protect the liner from imperfections because of subgrade defects or during the backfilling process.
Okay, Matt?
I'll just add quickly to that. There has to be some protection when you're using any kind of stone, even clay that hasn't been sifted through. So much damage is caused from rock punctures. And so when you have rocks anywhere near a liner, you have to protect the liner from those rocks. If we go to a job site and see that there's no protection and rocks in the liner, we're gonna change our flight home because we know we'll be there a while because there's gonna be dozens of leaks.
Exactly.
Great, good. Next question. From the presenter's experience, what is the maximum side slope for ponds not more than 3 to 4 meters deep? And Brian, if you could take that.
Yeah, I'm not quite sure I totally understand it, but well, we typically will look at the slope angle again, and we've been involved with flexible membrane liners and very, very deep ponds, in excess of anywhere from very common for us to have ponds that are 20 to 40 foot deep, and we could have slopes upwards of 100 feet. Things that we look at, of course, is the liner going to be backfilled, requiring a soil covering over top of it, or is the liner going to be exposed? And that really, in many cases, we look at the slope angle, then we look at it very closely at the anchor trench and compaction, the interface friction between the soils and the materials, and that really is all the criteria that we need to look at. But certainly these flexible membrane liners, can certainly be, we can have slopes in excess of 100 feet and have many, many times, and they perform very, very well.
Yeah, Brian, I think this may be asking the slope inclination. Like you said, it's not clear. So, for example, 3 horizontal to 1 vertical, or say 2 horizontal to 1 vertical. What would be, say, the maximum?
Well, again, I would think that, again, we're not concerned with slope lengths of upwards of very common to see us in those, say 3 to 1 slope. We can see slopes that if you're 12 meters deep, we can certainly handle those slopes, which are somewhere 50 to 60 feet. Not really a concern. Again, we would look at what is the material type, and are we backfilling it or non-backfilling it, and of course the anchor trench detail and the type of material that we're loading in the anchor trench. Those are kind of the critical type questions we ask ourselves.
Okay, great. Next question. When prefabricating panels, is there a specific material that is best to use, or can you prefab any material? My interest is 40 mil LLDPE, 50 and 60 mil HDPE. What is the maximum size for panel? Is there a maximum weight? How do you get past staggered welds when joining these systems on slopes? So, Rohit, maybe you could start with that one.
Yeah, sure. I mean, there's a lot of questions within this question. Now, if you want to fabricate geomembranes in a factory setting, I think one of the things that you have to look at is how flexible your material is. Because if you're looking at, as Brian said, I mean, 4,000 to 6,000 pound panel, there'll be a lot of creases and things like that you have to, look at. So it's very critical, for you to look at some of these details, if you want to really select a material for prefabrication. Your interest to use 40 mil LLDP, it's a great choice. I think we have done some testing here in the facility where we have tried some 60 mil flexible polyolefin geomembranes where we were able to make a panel that was about 10,000 square feet. But again, I mean, that material is not commercialized, but it is possible. But for now, I think we can fabricate a material that's like an LLDP type material that's 50 mil thick. With 60 mil HDPE, unfortunately, because of the yield elongation and yielding of the material, you can't really fabricate HDPE because those deformations are permanent. Because if you try to impart loading on those creases, you have kind of permanently deformed HDPE, and I mean, you've probably reached the point where the geomembrane has failed. So that's one of the reasons why 60 mil HDPE, even 40 mil, 50 mil HDPE, they're all field placed and they're not factory fabricated. What is the maximum panel size for maximum size for the panels? I think Brian did mention 4,000 to 6,000 pounds, and it's again what the contractor on site can handle. I mean, if he's got the right equipment. I think there was a time where we produced a 10,000 pound panel, but we had closely worked with the contractor or the installer to ensure they have the right equipment to handle that kind of panel on site. Is there a maximum weight? Yeah, 4,000 to 6,000 pound is something that you want to look at, and again, it all depends on the equipment the contractor is using. How do you get past staggered wells when joining these systems on slopes? I think with fabricated panels, you can minimize horizontal seaming on the slopes, which is probably an ideal case scenario. During field placement, you often see staggered wells, which are part and parcel of the installation technique. I'm not exactly sure, I mean, what your question is, but like in terms of horizontal wells on the slope, I think everyone who designs around geomembranes would actually want to minimize having horizontal wells on the slopes, just because of the shear and peel strength of the materials.
Right. Okay, thank you. Is there a maximum thickness for which prefabricated panels can be made and shipped to the site? For example, can a panel be made out of HDPE, 80 mil HDPE? And Rohit, I think you already answered that, but Brian, could you answer this question? And what could be the thickest flexible material? Could it be 80 mil as a more flexible material?
Well, I think the industry is going to get there, Tim. It's a very good question. And, so today, we are actually fabricating and supplying a fair amount of 60 mil material. We see 60 mil PVC, typically unsupported, going into large dam facings. There's some new generation linear low density resins that are more flexible that are coming onto the market from the resin producers, and we've been developing and testing 60 mil linear lows and CSPE material that's used a lot in potable water, very commonly specified in potable water storage at 60 mil. So there certainly are a fair amount of 60 mil products being used today, and I would think those materials, we could certainly providing we can manufacture them, and certainly a lot of improvements on the manufacturing side, whether it's whether it's polyethylenes or vinyl materials. Certainly 80 mil is very doable. As Rohit mentioned, HDPE, we certainly don't recommend fabrication of HDPE really of any thickness because of, as Rohit mentioned, the yield concerns of bending, increasing the materials, relatively low yield on the medium and high density materials of around 12%, and potentially to even propagate future stress cracking around those folds with HDP. So we normally take all HDP and field weld it.
Right. Okay, next question. Can you recommend any best international practice guide for double line containment systems? And Rohit, let me send that question to you.
Oh, thanks, Tim. I think there are state regulations, state guidelines or design practices, for constructing double line containment systems. A few things come to my mind are, besides the material, constructability is one of the key things to consider, when you're looking at designing around double line pond. I mean, whether you want to remove your your contaminant from the sump, using gravity flow technique. In landfills, it's common to see vertical manhole extending up from the sump. May not be applicable to many containment ponds. But one of the things that's very popular these days is the removal by like a sidewall riser pipe, which is connected from a sump to a monitoring shed, which is not very far away from the pond itself. So this riser pipe is about 600 millimeters in diameter, and it works very well. Matt also talked about a little bit about leak testing on a double line pond. As he mentioned, a lot of states are now looking at doing leak testing not only for the secondary, but also looking to do proper leak detection for primary geomembranes. So those are some of the key details, and I think I mean, if you look at my case study on FGI's website, the Spotlight, I think we provide a lot of things which are needed to ensure a good double line containment system.
Great, thank you. Next question, and it regards leak location testing. So with a conductive underside, Matt mentioned that the excess flap on the underside of a welded seam needed to be cut off to prevent false positive when leak location testing. Do you see installers typically using the welders that will be able to cut off this flap, or is the equipment not in common use yet? I'm curious as to how much of a problem the excess flap is anymore, or whether it's been essentially resolved. So maybe Brian and Matt, if you could handle this question.
Yeah, Matt, I'll let you take the first crack at that.
Okay, so what we see when we do a survey on conductive geomembrane is over half of them are not welded properly. I wish this wasn't the case, and I don't have the exact numbers. The problem is when there is a pond of any size, a site of any size, that those welds are not done correctly, there's so much conductivity on those flaps, it basically renders the site untestable, especially when there's soil cover or water cover. The best you could do is have it clean and dry and do a spark test on it. And again, it has to be pretty clean and pretty dry to do that kind of a test. But any kind of cover material on it, it's not testable that way because there's just too much interference with those flaps. So again, it's more common than not to see it that way. And I don't know if there's a disconnect there with the provider of the materials on what needs to be done and how they should be welded, or if it's a we have an issue, now what do we do, and it's too late to go back and fix the flaps. So it's still an issue, and hopefully it gets better.
Yeah, from an installer's point of view, it is a challenge. There are welders out there that have been developed that to help break the isolation. Again, they're tricky. They don't always work that well. You can make adjustments to standard wedge welders to try to squeeze out the conductive layer, trying to get what we call squeeze out. You can extrusion weld, you can tape these. It's a challenge, you know, trying to break the isolation and or to you know, for certain types of testing. And I know, Rohit, you've been involved with some testing on conductive geotextiles. I don't know if you have any comments on that.
Oh, yeah, definitely. I think conductive conductive geotextile, you know, definitely has got some key advantages. And again, you get uninterrupted flow underneath your geomembrane. You can test your flaps. You can just use standard techniques to you know, put your geomembrane together. Again, something we can discuss, or if you're interested, you can you know, you can look at our website for more information on conductive geotextiles.
Yeah, there's certainly in the industry the deal with some of these problems from an installer point of view, and the problems breaking the isolation at that wedge point. You know, it is there is some innovation and new technology and around the world coming on stream with these new conductive geotextiles.
Great. Thank you. Next question, second to last. How do you make a conductive geomembrane? That's a difficult question. Rohit, why don't you start with that?
For sure. I think many manufacturers, especially the blown film manufacturers, I mean, you know, if you look at the blown film extrusion process, I mean, you know, you got you know, primarily like 3 layers. You got a core layer, and then you have a outer layer and an inside layer. So what you do is you use you know, carbon black. I mean, usually when you look at the normal black geomembranes, you have carbon blacks anywhere from 2 to 3%. But we elevate the percentage of carbon black in one of the inside layers and create a layer that's conductive. And you can actually do some surface resistivity testing to see you know, the conductance of this material. So one side, the top side is non-conductive, and the bottom skin layer is conductive. That's how you create a conductive geomembrane.
Great. Okay, last question. GCL moisture for leak location testing. If the typical as delivered GCL moisture is not sufficient for leak location testing, what is the best way to add just enough moisture without adding too much, obviously with the bentonite and the GCL? As stated in the presentation, most if not all design engineers prefer not to allow the GCL to wet and hydrate until it's loaded. So Matt and Rohit or Brian, if you can answer this question.
Matt, do you want to take a stab? I think they're referring to you know, the things you said in the webinar.
Right, I agree. A lot of installers don't want to wet that GCL. They want to put it in there, and then if there is a leak, they want it to plug the hole, which it does very well. What works best is install it normally, put the liner on top, and if there is a rain event, if it rains out at the site, that will typically wet that GCL in the spot where the leak is at. Now the concern or the situation you have now is to get that wet spot on the GCL back to anywhere you have your ground electrode, in this case, double line systems between the liner. So that can travel back through the GCL, but if it's too dry, it won't get back there all the way. So you have a couple of options. You can put a copper wire between the liners, and that will help bring it back, kind of like a quicker shortcut back to your ground electrode. Or as we've talked about before, you can use a conductive geotextile. So as long as that conductive geotextile is touching that one wet spot in the GCL where the leak is actually happening, it'll bring it back to anywhere that you have your ground electrode and allow you to do the test. So this way you don't have to wet your GCL, leave it as it is delivered. You're going to use a fabric, so use conductive fabric, and that'll bring the current back and allow you to do the test, and you kind of get the best of both.
Yeah, thanks. That was something that I was going to add. But yeah, you can look at some of the new technologies that are out there, like a conductive geotextile, and it can definitely aid with leak location underneath a GCL that's not moist enough.
Okay, thank you very much. I'd like to thank Brian, Matt, and Rohit for joining us again and answering these questions we received during the webinar and after the webinar. Thanks for attending, everyone. The webinar will be posted on the FGI website. If you have additional questions or would like additional information, the contact information for Brian, Matt, and Rohit is in their PDF of their slides, or you can contact me at fabricatedgeomembrane@gmail.com or visit the FGI website at fabricatedgeomembrane.com. So Brian, Matt, and Rohit, thanks for joining us again, and take care.
Thank
Our
you.
pleasure. Thank you.
Thank you very much.